Hi everyone, my name is Tikeswar Naik. I'll be teaching physics. I'll focus mainly on NEET and JEE, but you can also use these videos for Physics Olympiad or AP Physics. Over the next few weeks and months, I'll cover full syllabus. I'll provide practice questions, mock tests, video solutions, and a platform where you can clear your doubts. This is an intro video. The main purpose of this video is to share two important messages for JEE and NEET aspirants. All right, but before I tell you the message, I want you to solve this problem. A person of mass m is standing on one end of a plank of mass big M and length L, resting on ice. The person moves from one end to another end and stops. The plank will move by distance. There are 5 choices and you have to choose the correct choice. But since I have not taught you physics yet, let me explain why the plank will move. So this is a person walking. When we walk, we push the ground backward, and the ground in turn will push us forward. That's how we move forward. But if we are standing on a slippery surface like ice, right? In this case, I have some rollers. When you push the ground backward, the plank will also move backward. And as you can see here, I have a toy car and that goes on a plank. The plank is resting on some pencil so that the plank is slippery. As the toy car moves forward, as you can see, the plank will move backward. Okay, so that is the concept. Knowing that, this is a good time to pause the video and give it a try. I'll see you in 10 minutes. Hi, I'm back. If you solve the problem, congratulations. If you're not able to solve the problem, no worries. How about I give you some hints? The first hint is think about unit, meaning we are looking for the distance, right? So which of these different expressions represent distance? That is the first hint. The second hint is think about limit, meaning here the problem say a person of mass m, but what is relevant here is the mass, not whether it's a person or animal or an ant. It doesn't matter. What matters is the mass. So what if instead of a person it is an ant? What will happen? How much the plank will move? So these are the two hints I will give you. So give it another try. I'll see you again in 10 minutes. Hello, I'm back. If you solved it, good job. If not, no worries. We'll solve it together. But before I show you how to solve this problem, let's look at some simpler examples. We'll look at 3 examples. This is the first example. The question is, which is the longest river of Nepal? Now, if you are well versed with the geography of Nepal, you may know the answer, but most of us are probably not. So, one intelligent thing to do will be, let's take a look at the choices and use some intelligent logic. So, it is asking about a river, but the choice says Everest mountain. It is a mountain, so it cannot be the correct choice. It says tiger, but tiger is an animal. It's not a river, so that cannot be the correct choice either. It says it's a river. Okay, river is possible. Now it says it's a chart. Chart is a food, so this cannot be the correct choice either. And since there is only one correct choice, C must be the correct choice. Now you may be thinking, what is silly questions and what does it have to do with the uh, original question, right? It has to do a lot, and we will see very soon. Okay, this is the second example. You bike half of 40 km with speed 20 km per hour and then walk the rest of the distance with speed 5 km per hour. What is your average speed? All right, let's try to solve this step by step. Average speed, let me denote it by V bar. It's just a symbol. By definition is the total distance over total time. So total distance I know is 40 kilometer, but do I know the total time? I don't know the total time. So let me calculate that. Time taken by a bike, this is going to be, first of all, half of 40 is going to be 20. So 20 kilometer I'm going in bike and 20 kilometer I'm walking. The time taken in bike is going to be, I'm going at 20 kilometer per hour, so that I'm traveling 20 kilometer and going at 20 kilometer per hour. So kilometer cancels, 20 cancels, this is 1, so this is going to be 1 hour. Similarly, time taken for walking, so T walk is going to be the rest of the distance, which is 20 kilometer again. I'm going that by walking, and I'm walking at 5 kilometer per hour. So 5 kilometer per hour, kilometer cancels, so this is going to be 4, this is going to be 4 hour. So then average speed is total distance that I know is 40 kilometer divided by total time. Total time is going to be time it takes for bike and time it takes for walking. So 1 plus 4 is 5 hour. So this is going to be 8. So this is going to be 8 kilometer per hour. And then if you look at the choices, B is the correct choice. So this is a proper way of solving the problem using the concept of average speed. But can we solve it another way, given that there are some choices? All right. So let me call this first approach. So this is the second approach. So here we are not going to do this elaborate calculation. We'll just first take a look at the answers. So it is asking us average speed. So speed is measured in kilometer per hour or meter per second or things like that, right? But we can clearly see the last two choices is asking for speed, but this gives me a distance. Like the previous silly example that we saw, it was asking for river, but one of the choices was a mountain. Similarly, it's asking for speed, but it's giving me distance. It's like asking for river, it's telling me a mountain. So it cannot be the correct choice. Similarly, asking for speed, but this is giving me time. So this cannot be the correct choice. All right. So first, we are taking a look at unit. Okay. So both these have the correct unit. So we are good. But can we do another intelligent thinking? So we have two speeds. We are biking with 20 kilometer per hour and then walking with 5 kilometer per hour. So the average is going to be between 20 and 5, right? Or 5 and 20, right? It cannot be more than 20. It cannot be less than 5, right? So that means it cannot be 25 kilometer per hour. That is more than 20, right? So this cannot be the correct choice. Two, then, so the second we are looking at, I call it bound. We are looking at the bound. Where should the answer be, right? And using the bound, we realize that this is out of bound, then again we get the same answer, right? But take a moment to think about it. In the first approach, right, we had to do some computations. It took us some time, but in the second approach, just by looking at the different choices that are given to us, we can know that this will be the correct choice, right? So you can see the power of this second approach, right? What would take us a minute or so will take here just few seconds. Take a look at the last example. This is same as the example before, except here I'm using the symbols. There in the previous example I was using numbers. Now you bike a fraction f of total distance L with speed v and then walk the rest of the distance with speed w. What is your average speed? Again, it is asking for the average speed. Now here we will just use the second approach. Meaning we are not going to actually solve the problem, but we will try to look at the choices since they are given to us and see if we can make intelligent guess, right? So first let's take a look at the unit, right? So it's asking for speed. Speed should be in meter per second or kilometer per hour, something like that, right? Now if you look at this one, length is usually in meter, the speed is in meter per second, so meter cancels out, so this is second. So it's asking for speed, but this is coming in second. Like again, compare with the first silly example, right? It's asking us about a river, but this is telling a mountain, right? So this cannot be it. All right, now, okay, looking at the unit, we rule that out. Now let's try to think more, right? So we are walking a fraction with a given speed, another, and the rest with another speed. So clearly the average speed is going to depend on the fraction f, right? And if you look at this choice, there is f doesn't appear here, right? So this cannot be the correct choice. Okay, now all right, let's think more, right? The next thing to notice is the fraction is going to be anywhere from 0 to 1, right? The fraction can be 0, 0 0.2, 0 0.3, all the way to 1, right? Anywhere in between 0 and 1. So what if f is equal to, just for the sake of example, what if f is equal to 1? What does that mean? I'm biking the whole distance, fraction is 1, right? So I'm biking the whole distance with speed v. That means if I'm biking the whole distance with speed v, the average speed should be v, right? So in this case, average speed, let me call it v bar, this should be equal to v, right? So let's look at the remaining two choices and see which one obeys this, right? So if f is equal to 1, this is going to be 1 minus 1 is 0, so this is 0. F is 1 times w is w, so w and w will cancel out, v remains here. Similarly here, 1 minus f is 0, so this term is 0. This is just v, so v and v will cancel out, w remains here. So but I'm expecting when f is equal to 1, I'm expecting v, then this must be the correct choice. This cannot be the correct choice. So you can see, so again, so I call this limit. In the limit, when fraction is 1 or 0, we can also try the same thing with 0 and see if it makes sense. But as you can see, in some of the problems, you can use some tricks, some logic to solve it very, very fast, right? This is actually a very simple problem, so I encourage you to, using the first approach, using the concept of average speed, actually work it out and make sure that you get the same answer. That will be a good practice. All right, now back to the original problem. So I had given you two hints. One was to look at the unit, and second was to think about limit, right? When the mass goes to 0. So let's first take a look at unit. So we are looking for distance. So distance should be in meter, kilometer, things like that, right? So taking a glance at the choice, let me first take a look at this one. Actually, let's look at everything, right? So L, length can be in meter, mass is in kg, over this mass is going to be in kg too. So kg cancels. So this has the unit of meter, which is good. Similarly, you can see here, this will also have unit of meter. This is going to be on the numerator is going to be kg, and here meter times kg. Kg cancels. So this is going to be in 1 over meter, right? Here it is going to be in meter. Uh, here it is going to be meter on the top, and then kg on the bottom, meter by kg. So again, it is asking us for distance, so we are expecting the answers to be in meter. So in this case it is meter, this is meter, this is meter, but these two, this and this, they are not, they do not have the right unit. Meaning it's asking for a river, one is telling it's a mountain, the other one is telling, it's an animal. So it's not going to work, right? So clearly this and this are not going to work, right? Now the other hint that I had given is, what if it is not a person but it is an ant, right? It's an ant. That means ant has very small mass. So the mass, in the limit, mass goes to 0, or very, very small, very negligible compared to the mass of the plant, right? So let's think about it. If the, on the plank, which is on a slippery surface, if an ant crawls on that, I can imagine that if I walk on it, I will the plank will slip, it will go backward, right? But what if an ant crawls on it? It is, the plank is not going to move, right? So that means when, in the limit, when m goes to 0, I expect the distance, let me call the distance by d, that also should go to 0, right? So let's see which of these expressions obey this. If m is 0, so this is 0. Now this is a finite number divided by a small number, so this is going to be a huge number. This is going to be a huge number, right? So clearly this is not going to work because we expect the distance to go to 0. Let's take a look at this. Mass is 0, so I can cancel that. So this is a finite number, so m goes to 0, so this whole thing will also go towards 0. So this looks like a good choice. In this case, if mass is 0, I can strike that out. This mass will cancel this. What remains is L, but we want it to go to 0, right? So clearly this is also not going to work. Then B is the correct choice. So you can see the power of this technique, right? So this specific problem we were able to solve without using the concepts of physics, right? All right. So that is not a one-off problem. I didn't just make up that problem. Actually, problems like that do appear in NEET and JEE. These are the actual problems from those entrance. If you look at the first problem, this one you can simply solve using the limit technique. That's it. You don't need anything else. You don't actually need to um, uh, solve it using the concept. You can simply use limit, and just by looking at it you can solve it. Similarly, this question you can simply use unit, this one simple trick to solve this question. I'm not saying that every problem in NEET and JEE you can solve by these tricks, but when it works, it can really make a difference in terms of how fast you can solve it. Now, those who score good rank in this entrance, right, they are very, very well versed with these different techniques. And we will actually, I will make a separate video. There are several techniques that you can use to solve problems really, really fast. But those who score good rank, they are actually very well versed with these different techniques. And looking at a problem with enough practice, they will know if they can use some of the techniques to solve these questions very, very quick. Actually, I encourage you to try to solve this using limit and solve this using unit, and uh, let me know in the comment section. But let's keep going. Okay, I want to give an important note about the expressions. So these are all expressions, right? These are all expressions, and expressions are everywhere in physics and engineering in general. You'll see them everywhere. Now listen to their whispers. This is very important. Always try to ask, what is it trying to express? It is called expression because it's trying to express something, right? So ask yourself, what is it trying to express, right? And how does it vary? Like, if I vary the different parameters, how does the value vary, right? So that kind of thinking is extremely useful, not only for solving multiple choice questions, but even beyond that. All right. Now, getting to the point, why did I ask you to solve that problem? right? Before teaching you physics. Why did I do that? Let me tell you a small story. You know, during our school days, we went to our teacher and said, "Teacher, we want to prepare for engineering. So can you please prepare us for REC?" So at that time, currently it is called NEET. NEET. At that time, it was called REC, Regional Engineering College. Right now, it is called National Institute of Technology. But the teacher said, "Why REC? Prepare for IIT." And we are like, "Okay, what is IIT?" We didn't even know about IIT. Now, we talked to our seniors, and they told us that nobody makes it to IIT, so that's why nobody talks about IIT. So don't waste your time. Focus on REC. So we went back to our teacher and said, IIT is beyond us. Please prepare us for REC. And what he said is, okay, fine. This is a year question from IIT. Please give it a try. Just a try. Now, we had already made up our mind that IIT is beyond us and that is not going to happen anyway. So we just stared at the questions and then looked at each other's face, right? Nobody even tried. Now, next, what happened was a turning point in my life, right? What the teacher did is he took the problem and used very simple concepts in math and physics. And the seemingly difficult problem, he solved it with ease. And the moment he solved it, literally, that was the turning point. We thought, wow, this could have been, I mean, if only we had tried, right? We didn't realize, I mean, I could not think that that was so easy. We had the preconception on that the problem was going to be hard, but that was not the case, right? Now, at this point, the teacher gave us a message that I'm going to share with you. That is the main point of this video, right? He said, actually, it's all right that you are not able to solve this problem. That's totally all right. But remember this message. And the message, and as they say, the rest is history. All right. So, what is the message? The first message is about the mindset. The teacher said, you see, I gave you this problem because I knew that the concept that is needed to solve this problem, you already know that the basic concepts in math and physics, you already know that, you have already learned that, right? So your mindset should always be, I'm getting this problem, I'm given this problem because I should be able to solve it. That should be the mindset, right? Now this is true for NEET JEE and also life in general. Like, we get different setbacks, problems in life, where our mindset should be, okay, I'm getting this problem because I should be able to solve it, right? So there's the first message. And the second message is mehnat, meaning hard work. It's okay, you should be able to solve it, but it's not like you don't put any effort and go straight in the exam and or say that, oh, I should be able to solve it. It's not going to work, right? You have to work for it, right? And how do you work for it? You have to learn the right way and practice. That is the key, right? We will discuss these messages in detail in the next slides, but I will tell you one more thing here. Please do not fall in a born genius trap. What is this trap? Sometimes you'll see your friends will come and tell you, hey, you don't really need to practice that much, you don't really need to study that much, I study just before the exam and I do great. And you will see that some kids do great, right? But not most of us are not born Einstein, right? We have to work hard to acquire skills, right? There's the first point. The second thing is, you actually don't know the backstory. They may be working hard and pretending that, they are not working hard. That is to minimize the competition, because these are competitive exams, right? The less the competition, better it is, right? So don't fall in that trap. You have to practice, you have to work hard. All right, regarding the first message, you should be able to solve, but you have to remember that everything is hard before it is easy. The first time when you were a baby, you were not able to walk. It was very difficult. You fell down many times before you were able to take the first step, right? Similarly, while biking, you fell down many times, and now at this age you don't even think, you don't have to think how to walk, right? Or you don't have to think how to bike. It just comes to you naturally, right? So remember that everything is hard before it is easy, right? And the second quote I have put here is, a smooth sea never made a skilled sailor. Meaning, if it was easy, you are not learning that much, right? If I just gave you simple problems, 2 plus 2, I know that you can do it with very ease, but you are not going to learn much. When you were a baby, that made sense. For a kid, you can ask 2 plus 3, then they will count 1, 2, and then 1, 2, 3, and 5. It made sense for them. But at this stage, you have to try hard problems. That is the only way you are going to improve your skill. And the last but not the least, focus on winning the war, not every single battle. So what the teacher said is, you got this problem, you didn't get this problem, that's totally all right, but learn from it. So that should be the focus. The second message was about you have to learn the right way and practice. So what does it mean by right way? So when it comes to physics, there are three key things I really want you to remember. One is the concept, technique or trick, and practice. These are the three important ingredients to learn the right way. Concept gives you accuracy. If you have your concept clear, you can solve a problem accurately. You'll get it right. But when it comes to competitive exams like NEET and JEE, concept alone is not enough because there is a time limit. You also need speed, right? So oftentimes there are some techniques and tricks that can help you gain the speed, right? So you need accuracy, you need speed. But accuracy and speed, they are not going to come just like that. They are not just going to happen overnight. You need to practice. With practice, can clearly see, okay, for this problem, I can use this technique, right? So that comes with practice. And if you practice enough, that will give you consistently. Not only you will do it accurately and fast, but you will do consistently, right? And that whole thing will give you the confidence to appear in the exam, right? All right, I'll give a simple example, you know, to explain this a little bit more. I'll take the concept of average. I'm taking this concept because everybody knows at this point what is average. The concept of average is, if you have, let's say, numbers x1, x2 until xn, what average means is add all these numbers and divide it by the total number. So this is the concept of average, right? So if I give you two numbers, let's say 3 and 5, and if I ask you the average, you should know what is an average, right? You should know that you add the numbers 3 plus 5 and divide by how many numbers I'm adding. I'm adding two numbers, so it's 8 by 2. This is going to be 4, right? So if you have the concept right, you will get the correct answer. But let's say if I gave you many numbers, right? Say I say 29, 30, 31, or all the way until 287. Well, of course, you have the concept right. You can add 29 plus 30 plus 31 and compute it, right? You can do it that way. But you can also use some tricks. So this is an arithmetic progress, right? Arithmetic sequence. So in this case, the average is going to be the same as if you just took the first number and the last number and calculate the average of that. So I can just add 29 plus 287, and I'm adding two numbers, so I'll divide by 2. So whatever this comes out will be the average, right? So there is a small trick I used to do it fast, right? So I'm not only using the concept, but I'm also using some trick here. And how does practice come into play? In problems, it is not many times, right? After 10th grade, in competitive exams or in real life, many times it is not going to ask you straightforward to, okay, these are some numbers and calculate the average. The question is going to come in many different forms, right? Something like Ram has many cookie jars containing this many cookies. He wants to distribute the cookies equally in jars. How many cookies will eat jar have. So when you read this question, it should come to you that okay, it is this here I have to apply the concept of average, right? And this comes up through practice. So when you practice many questions, right, it will come to you, okay, for these questions I have to apply this concept and this trick, right? That's why practice is very important. I cannot actually emphasize enough how important practice is. All right, going back to our original problem again, right, to highlight this, uh, to emphasize again the importance of concept, techniques, and practice. Of course, this problem is based on some physics concepts, and the concepts are actually center of mass. Center of mass. We are going to read about this very soon, and conservation of linear momentum or Newton's second law, either one. Right? You can use these concepts, and you can derive you can derive the exact result, right? But that will take you maybe a couple of minutes because you have to write down the equations and do the algebra. So it'll take you maybe a couple of minutes. But if you look at this problem and think about it, and if you know some techniques and use those techniques, you can do it in 10 seconds or less, right? Those who score good ranks in exams, they can see a problem and see if they can apply some techniques and can do it fast. Again, not every problem you can do it like this, but the problems that you can apply some techniques and do it fast, that gives you a lot of time and upper hand compared to the other students, right? So it is very important to know not only the concept but also the technique so that you can gain speed, right? Finally, practice. Why is practice important? For a problem like this, right, it is not asking, okay, calculate the center of mass or use conservation of linear momentum. It's not asking you that straight, right? It is giving you a problem. It expects you to find answer. So the practice will tell you, okay, looking at this problem, with practice you will know that, oh, this is a problem where I can apply the concept of center of mass, or concept of center of conservation of linear momentum, right? That comes only with practice, right? Okay. Again, how to really get a good handle on concept. So what we will do is, in the videos, we'll actually use very simple derivations to explain the concept, right? We'll also do some simple demo experiments and animations so that you can get the feel of the physics behind it, right? Now for techniques, you know it's like a very sharp knife. It can be very useful if you know how to use it properly, but if you don't know how to handle it properly, it can actually hurt you. So yes, tricks are very powerful, but you also have to know how to use them properly, right? The tricks work like magic, but they are not magic, right? All right. And the last is practice. So that you can get a good practice, we actually, if you go to our website, this is still a little bit under construction, but you will get a lot of questions which you can practice at your own time. To end this video, you know again, I want to emphasize on the two messages. That was the key point of this video. The other things were basically that helped me lead to this message, but the key message is, your mindset. Every time you get a problem, it can be NEET JEE or later also in life in general, your mindset should be, I'm getting this problem, I'm given this problem, or this problem is uh, on me because I should be able to solve it. That should be our mindset, right? And then, but I should also know that I have to work for it. Always think how to solve this problem instead of can I solve this problem, right? So that is it for this first video. I'll see you in the next video. Thank you.